In our daily lives, we often witness changes happening around us. Some changes are temporary and can be reversed, while others are permanent and cannot be undone. These transformations of materials are fascinating to explore, and by understanding them, we can gain valuable insights into the world of science. Hi, my name is Stefan, and today we will explore the concepts of reversible and irreversible changes. Reversible changes. Reversible changes refer to alterations in materials that can be undone, allowing them to return to their original state. These changes typically involve a temporary rearrangement of particles without any new substances being formed. Let's explore some common examples. Melting and freezing. Take an ice cube as an example. When heat is applied, it melts and transforms into water. This change is reversible because when the melted water is cooled, it freezes back into an ice cube. Dissolving and crystallization. When you mix salt and water, it dissolves, forming a salty solution. However, by evaporating the water, the salt can be recovered in its original solid crystal form. Changes in shape. Materials like clay or Play-Doh can be molded into different shapes. When we squeeze, roll, or shape these materials, they undergo a reversible change. The material can be reshaped or flattened back to its original form. Irreversible changes. Unlike reversible changes, irreversible changes cannot be undone or reversed. They involve the formation of new substances and often result in a permanent alteration in the material's properties. Let's explore some examples. Burning. When a piece of paper or wood catches fire and burns, it undergoes an irreversible change. The original material is converted into ash, smoke, and gases and cannot be transformed back into paper or wood. Cooking. When we cook food, various irreversible changes occur. For example, frying an egg turns the liquid egg white and yolk into a solid state, which cannot be reverted to its original raw form. Rusting. When iron or steel is exposed to moisture and oxygen over time, it undergoes a chemical reaction called rusting. The iron forms a new compound, iron oxide, also known as rust, which cannot be transformed back into pure iron without extensive processes. Identifying reversible and irreversible. To identify whether a change is reversible or irreversible, there are a few key factors to consider. Formation of new substances. If new substances are produced, it is likely an irreversible change. The difficulty of reversing. If it is challenging or impossible to revert the material to its original state, it indicates an irreversible change. Change in properties. If the properties of the material are permanently altered, it suggests an irreversible change. Understanding reversible and irreversible changes helps us comprehend the world of science and materials around us. By recognizing these transformations, we gain insights into the behavior of different substances and their interactions. Remember, reversible changes are like temporary alterations that can be undone, while irreversible changes bring about permanent transformations, forming new substances. So, keep exploring and observing the fascinating changes happening in your surroundings. See you next time.